Here we go. We have a question. Find the count of good integers. You are given two integers n and k. An integer x is called k palindromic if x is a palindrome and x is divisible by k. An integer is called good if its digits can be rearranged to form k palindromic. For example, we have given k as 2. So this number is my x. So we can rearrange this x to make a palindrome, and this x this is a palindrome. This is also divisible by k, which is my second condition. Whereas if we have given this number, we can rearrange to form palindrome, but then it will not be divisible by k, right? So this is not k palindromic. We need to return the count of good integers containing n digits. Note here is any integer must not have leading zeros, neither before nor after the arrangement. For example, this one cannot be rearranged to 101, right? So the first example is this n3 and k5. So we need to make integers whose digits is 3 and also divisible by 5. So first variable is 551. So this can be rearranged to form palindrome, and that palindrome is also divisible by k. The next value will be 525. This is palindrome and also divisible by k. So there are in total 26 values who has 3 digits, right? In the second example, we need to make integers, and that integer must have one digit and also divisible by 4. So we have two digits. One is 4, which has one digit and also divisible by k. The next value is 8. So in total we have two values. For this we have that many values, right? So that's all about this question, and the constraint is very low. So if we have so let's build the approach. If we have given this value, right? So what is the constraint for n? So n constraint is 10 only. And what is k? K is 9, I think. Yes. So we have 10 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So on any given slot we have 10 different options. 0 to 9. We have 0 to 9 options. We have 0 to 9 options. And actually in this we have 1 to 9 options only. And all the other values we have 0 to 9 options. Right. So we have 10 options. And so it will be 10 options, 10 options, 10 options. On any given slot we have 10 options, right? Actually in the first slot we have 9 options and every value, so it will be 9 cross 10 raised to power 9, right? So this will be my brute force. But can we optimize this? Yes, we can optimize this. How? We only care about palindrome values, so let's only build the palindrome values. So we have 7 slots, 4, 5, 6, 7. So we have 7 slot and 3 values here, 3 values here, and middle value can be anything, right? So we want to create different values, and if we place some value here, let's say x, so that x is also be placed here. If I place any value, let's suppose y, so that y is also placed here. So after the half portion we don't have any choice. We have to just reverse this original string and put it here, right? So for our odd length we only fill till 4, right? And for our even length 1, 2, 3, 4, 5, 6, 7, 8, for our even length we only fill 4 values, and the other half is just a reversal, right? So what we'll do, we have this, and this is a string. Our target length is 4 only, right? And the 3 slots is the reversal here. We only need to create a 4 length string, right? Here also we only need to create 4 length string. Our target is 4. So we can write it like this: 7 plus 1 by 2, which will give me 4. And we can write it like this: 8 plus 1 by 2, which is 4. Right? Yes. So we know. Now the first thing, what value will be here? We can so actually for any slot we have choices from 0 to 9. We have different choices, but for the first condition we don't have 0 to 9. We have 1 to 9. We have 1 to 9 choices. So what we'll do, if my string is empty, so initially my string, so I need 4 length string here. If my string is empty, I will not place 0. I will place first of all 1. I have 4 length only, so I will start placing from 1. Then in our next slot, what I will do, I will place 0 0 0. Right? So this will be my first string, and for the other half I will just copy value from this, so which is 0 0 and 1. Is it divisible? So this is palindrome, which satisfy my first point, but is it divisible by k? No. Then what I will do, I will try to make another value. Is it divisible? It is palindrome, but still it is not divisible. Is it divisible? No. Is it divisible? No. So using this, I will create different values. I will generate different values using my recursive function. So on any given point, so my value will look like this. So I will check if this is divisible by k. So I will create different values and check if my palindrome, if my string is divisible by k. If yes, so I will store it. Right? Is that this is just a simple recursive function, and this will store the answer. But we have one issue. What's the issue? So let's look for a case. Let's look for a case. Suppose my n is 4 only, and my target is 2. I need to fill 4 slots, but my target is 2. So I will just generate 2 case. I will just generate 2 length, and the other 2 is just a reversal of my first portion. So what value I will place here? I will place 2 4, and this is just a reversal for 2. And let's suppose my k is 2. My k is 2, right? So I have this thing. This is a palindrome. So I will also create its permutations, right? So what are its permutations? So permutation is also divisible by k. Permutation will be 2 4 4 2 2 4 2 4 4 2 2 4 4 4 2 2. So there are many different permutations, right? So let's apply the combinations. So we have 4 slots. I have 4 values in total here. I have 3 values, I have 2 values, I have 1 values. But how many duplicate values are there? So 2 occurs 2 times, so let's write 2 factorial. 4 occurs 2 times, so let's write 2 factorial. This will cancel out, which will give me 6. So I have 6 different combination for this. Let me write it. So I have these 6 combination, which is k palindromic, right? So these are 6 permutations. So my question become very simple. I just figure out, first of all, the length factorial, which is this length. Then I will figure out count of every single digit factorial, right? So this will be 4 factorial by 2 factorial divide 2 factorial. So this is good, this will work. But is there any edge case? Yes, there is an edge case. If we have 0 in it, so what if we have 0? So let's suppose my value is 1 0 0 2 0 0 2, right? So this is palindrome, also divisible by k, right? So how many different combination we have? So this, you think this formula will work, which is the length factorial by 0 factorial by 2 factorial, means count of 0 is 2 and count of 2 is also 2, so which will give me 6. But there is a condition, so let me write the 6 permutations. So we have these 6 permutations, but as you can see, this is invalid because we have leading zeros, and in the problem it clearly says that we don't want leading zeros. So how do we ignore this? So what I will do, I will first create these 6 permutations. It means we have 6 combination. Then I need to subtract the 0 permutation from it. So how do we calculate this 0 permutation? For our 0 permutation, what I will do, I will fix my 0 here, and we have 3 length. We have 3 length, right? So we have 3 different choices here, 2 different choices here, and 1 different choices. Like I did here, which is length factorial. Same, if I want 0 in my 0th place, I have length minus 1 factorial choices for the other slots. For the other slots, length minus 1 factorial choices. And so let me change the color and write it here. So for our 0 permutation, I will fix 0 on first position, and for the other positions I have length minus 1 factorial choices. Then I also need to subtract, like I did here, which is the count factorial. It means how many times 0 occurred. 0 occurred 2 times, but 1 is already fixed, and 2 occurred 2 times. So I also need to check the count factorial, but this count factorial is there's a special case for 0. It means we have already fixed 0. So for 0 we have count, we have frequency minus 1. For 0, for 0th value, we already placed 1 0 in the 0th place. Then we have 1 less 0, right? So let me give you another example. So we have this many slots, and this is okay, odd will also work. So let me write, my n is 7, my k is 2. So let me create the permutations, also divisible by 2. So 2 0 0 and 2 2 and 5, right? So what I will do, I will first find the 7 factorial length. Then 2 occurs 4 times, this is count of 2, and we have 0 occur 2 times, this is count of 0. So this formula also includes 0 in front, right? but we don't want this. So what I will do, I will subtract uh, 0 permutation from it. It means I don't want 0 in front of this. So if I fix 0 here, I have this length minus 1 choices, right? So I have 6 factorial here, which is length minus 1. Then I also need count of 2. Count of 2 is 4 factorial. This is count of 2, and I also need count of 1. Count of 1. But why I am subtracting? Count of 1 is 2. Count of 0, sorry, this is count of 0. Count of 0 is 2. But why I'm taking 1? Because count of 2, count of 0 is 2, we know, but 1 0 is already fixed here. 1 0 is already fixed here. So that's why we have 1 less count of 0, right? So that's why for 0 I have to take 1 minus, right? So what if my string will look like this: 5 here and 5 here. So this is palindrome, not 5, 0 and 7, 0 and 7, right? So this is my middle point, and this is a palindrome of this. This is just a reversal, and this is a palindrome and also divisible by k. Then here count of 2 is 4 only, count of 0 is 2 only, and count of 7, we also want count of 7. This is count of 7, and now we have 9 length: 1 2 3 4 5 6 7 8 9. Here also we have 8 length, because we have already fixed 0 in this place, and we have 8 length different choices, so that's why 8 factorial. Then this is count of 2, count of 0, and we also need count of 7, right? So that's how this will work. We only care about palindromes. We will only generate palindrome of length minus 1. So let's code this. First let's figure out the target length. If my n is 3, we want 2, so n plus 1 by 2. This is my target length. We have string length, and n and k. We have this, we have string, we have target length, we have n, we have k. We have 0 to 9 choices. If my string is empty, then we cannot place 0. We will just continue. Otherwise, we will place 0. And get the value from here. String plus ith value, my target n and k. Just return the answer. If my string length is equal to target length, then we are inside this. We need to check if my n is even or if my n is odd. If my n is even and I have placed 2 values, then I have placed 2 values, For the other values I just need reverse of string. Otherwise I want reverse, but so let's suppose my string is 5 and I have placed 3 values. So the first 2 values I need and the last value I don't need. So I will just write string, this is string, so I want string s dot length -1. So this will not include, so I am just taking a portion, this is substring from 0 and leaving the last character. And let me write reverse function. Reverse, we have given a string and I want reverse of this. So what I will do, I will create a string builder s, then reverse it, then convert into a string, right? So I have given this. Now my string length is n. I need to make sure that this string is divisible by k. So I will just convert into long. My string is divisible by k, then I will move forward. So this is divisible by k, then otherwise I will just return 0. If this is divisible by k, I want all the different permutation of this, all the different permutations. So what I will do, just calculate all the different permutation of str. Okay, so I have this calculate function, this return type calculate, we have this string s. First I want different permutation of string s. For example, my string is 551 here, 551, so I want all the different permutation of 551. Or if my string is 125 1, if my string is 1257 and 521, I want all the different permutation of this, right? So I will calculate it here. We have answer. First of all, answer is the factorial of length, then I will just divide it with how many count of every single character. So I want character count, so this is count, right? Then I will just iterate in this, and answer divide is equal to factorial of I. So it will include count of 1 as 2, count of 2 as 2, count of 5 as 2. So I will just divide it with factorial of I, just return the answer. But we need to also make sure, if my string contains 0, so I need to remove that many permutations. So first let me write the factorial. Factorial of x so I have written the factorial of x. If we don't have count of 0, so just return the answer. Otherwise we have count of 0. we need to remove the 0 permutations. Initially this is the length minus 1, and we just need to write a for loop count of 0 is subtracted by 1, and just write this thing because 1 0 is already fixed on the 0th position. Yes, so we need to make sure that we subtract the 0 factorial. It means we placed 0 in our first position. So 0 permutation, first we figure out the length minus 1, then count of 0 subtracted, then 0 permutation is divisible, is divided by every single value that occurred more than once. So just return this and we have calculated, and this will work, but we are missing one piece, that is I have already shown you in the whiteboard. So let's suppose, okay, let me write it. So if my length is 4 and the number is divisible by 2, so we have two slots here. What I will do, I will place this value, right? So it will create all the permutation. What are its permutation? Its permutation is 2 2 4 4 2 2 4 4 4 2 2 4 2 4 4 4 2 2 4 2 4 2 4 2 2 4, right? So we have created this, and if I jump onto this value, I will create all the permutation. But if I again jump on its different combination, for example 4 2 2 4, so I will again create all its permutation, which is 2 2 4 4 2 4 4 2 2 4 2 4 4 4 2 2 4 2 4 2 4 2 2 4. I will again create it, but this value is already included in here, right? So how do we tackle this? How do we tackle this thing? To tackle this thing, what I will do, if I jump onto any value, for example I will jump onto this value, I will sort this. So after sorting, it will give me this, and I will just save this thing. It means I have generated all the different permutation that can be made from this particular string. Then if I again jump onto a different string, this string, I will again sort this. So after sorting, it will give me this thing, and I need to check if this string is already traversed, if this string is already visited, so I will not calculate its permutation, right? So I need to make sure that whenever I am generating the calculation, I am calculating all the different permutation, I will save the sorted value, right? So I am missing this piece. So for that we need a string. This is not string, this is set. This is visited set. This is visited set, and if I calculate this, I need to make sure that I will save this string, and if this string is already saved, check if saved. If this string is already saved, just return back, right? So I need to make these two functions. First is check if saved, and I also want this save, and I need to save this. Right, we have given a string and we need to save it in a sorted format. So I will mm, create a character array, then I will sort this character array, then I will check if this character array is not possible. So I will create a temporary string. So I've created a temporary string. If this string is there, visited dot contains, if this string is there, it will return me true, otherwise it will return me false. For this save function, I need to create this and add it, just add it in the visited set. Let's run this, and working fine. Let's submit this, and working fine. Let's talk about time and space complexity. So this code is very big, but we need to figure out. So we have this solve function. So this solve function, its base case is the target. What is the target? Target is n plus 1 by 2, right? And for every single stage, we have 10 different combinations, right? So if I am here, my string is empty, so I have 10 different combination. I will either apply 0, 1, 2, 3 till 9. Again, for every single condition, I have 0 to 9 values. What its length? Its length is what is the length? Length is target. What is the target? Target is n plus 1 by 2, and we have 10 different combinations. We have 10 different ways. So its time complexity is 10 raised to power n plus 1 by 2. Are we doing anything else here? Just we are reversing this, and I don't think we are doing anything else. So time complexity is this, and we are just calling this function, solve function. It will generate the palindromes. This is the stopping condition. Then we are reversing. Then we are just converting into integer. Then we are checking if this check, and here we are sorting it. So in the sorting will take n log n, and what's the sorting will generally take n log n, and it depends on the length of the palindrome. So length of the palindrome is actually n, so it will be n log n. Then let's talk about space complexity. So in the space complexity, we are utilizing a set data structure. In the set data structure, it will, in the worst case, it will store all the different palindromes, and all the different palindromes is n plus 1 by 2. Each of palindrome has a length of n. So this is my time and space complexity. That's all. Thank you all for watching.